Hi friends, today I am giving a lecture on binary search. So before going to binary search, what is searching? So searching is the process of finding a desired element in the given list of n numbers. If the desired element is found in the list, so then it is called as a successful search. If the desired element is not found in the list, then it can be called as unsuccessful search. So there are two types of searches are there. First one is linear search and the second one is binary search. So linear search is the process of finding a desired key element from the given list of n numbers. Suppose if the desired key element is found at the first position, so then it is called as a best case. So best case of linear search, it can take big O of one time. Big O of one time. Okay. Suppose there are 5 elements are there, 10, 20, 30, 40, 50. So our desired key element is equal to 10. So first, the desired key element 10 is compared with the first element in the given array. So our desired key element is found at the first location in the given array. So then search is successful. So then it is called as a best case. So best case. So it can take only 1 unit of time, that is big O of 1. So with the first comparison, then we have to find that our key element is there in the given list at first position. So then it is called as a best case in the linear search. Suppose our key element is, so 30 is there. So then first comparison, 30 is compared with 10. It is not match. Next, 30 is compared with 20. Does not match. Then 30 is compared with 30, match. So our key element is found in the list. So where the key element is found, so there are array size is 5. Our key element is found at third position. Okay, third position is nothing but average case because array size is 5, but our key element is found at 3. So then this is called as average case. So average case is nothing but big O of n by 2. Big O of n by 2 is nothing but it is also big O of n. Big O of n. Next, suppose our key element is 50. Okay, so then how to find that our key element is present in the list or not? So first 50 is compared with 10. So does not match. 50 is compared with 20. Does not match. 50 is compared with 30. Does not match. 50 is compared with 40. Does not match. 50 is compared with 50. So then they matches. Our key element is found in the given list at 5th position. So first, second, third, fourth, 5th position. So array size is 5. Our key element is found at 5th position. So then this case is called as worst case. Worst case is nothing but our key element is found at the last position. So last position, then the time complexity is big O of n. The time complexity is big O of n. Okay, these are the best case, average case, worst case. So best case is nothing but our key element is found at the first location with the first comparison. So then the best case time complexity is big O of 1. Our key element is found at the middle position, approximately at the middle position. So then the average case, actually it is n by 2. N is nothing but size of the array. So big O of n by 2, that is nothing but big O of n. Next, third case, worst case, our key element is found at the last position, approximately last position. So then the time complexity is big O of n. So these are the possible cases in linear search. But if the element is found in the last, so we can require approximately n number of comparisons. Here n is nothing but size of the array. Okay, this is the worst case. Okay, next one. Next we can go to the binary search. So binary search is an efficient searching technique when compared to the linear search. How can you say that binary search is an efficient searching technique, so compared to the linear search? So in the case of binary search, at a time we have to search only one sub array and ignore the second sub array. So then half of the time can be saved. So that we can say that binary search is an efficient searching technique. Okay. Next, what is the necessary condition should be followed in the case of binary search? Suppose we want to search a key element among a list of n numbers. So the list of n numbers should be in sorted order, that is ascending order, compulsory. All the elements in the array should be in ascending order. So only in that case we have to search the desired key element, so in the list of given n numbers. Otherwise the binary search technique is not possible. Okay, this is also the disadvantage of binary search. In the case of binary search, suppose we want to search a desired key element in the list. Okay, the elements in the list should be in sorted order, that is ascending order. So at that time only we have to use binary search technique. Otherwise we do not use the binary search technique. Next one. So what is the element to be searched in the given list of n numbers? So that element is called as key element. Okay, which element to be searched in the list of given n numbers? That element is called as key element. Okay, next, how to search the key element among the list of given n numbers? Okay, now we have to find out the mid value. So mid value is equal to low plus high by 2. Low plus high by 2. By using this mid value, okay, our key element is compared with the mid value. Suppose our key element and mid value both are same, so then our key element is found at the mid position. Okay. Second case, our key element is compared with the mid value. Okay, our key element is greater than the mid value. So then we want to search the right sub array. Our key element is compared with the mid value. Okay, our key element is less than the mid value. Then we want to search the left sub array. Okay, these are the three conditions should be tested while searching an element in the list of given n numbers. Okay, so we are going to one example problem. So here A of mid be the middle element of an array A. Then there are three conditions that needs to be tested while searching the array using this method. If key equal to A of mid, here A is nothing but array, mid is nothing but low plus high by 2. So our key element is equal to the mid element of the given array. So then the desired key element is found in the list. Suppose if key element is less than A of mid value, so that is our key element is compared with the mid value, our key element is greater than the mid value, so greater than the mid value, so then we want to search the right sub array. Our key element is compared with the mid value, key element is less than the A of middle value, so then we want to search the left sub array. So these are the three conditions should be tested while searching an element from the list of given numbers using binary search. Next, what is the necessary condition to be followed? All the elements in the array should be in ascending order while performing the binary search technique. Otherwise, we do not use the binary search technique. Next, we go for example problem. So now consider the example. So there are a list of elements are there. So we want to search the key element, that is 60, is present in the list or not using binary search. So before solving a given problem, first we have to check the necessary condition, whether the given n elements are in the ascending order or not. So here 10, 20, 30, 40, 50, 60, 70. So there are 7 elements are there. These 7 elements in the array in the ascending order are there. Okay, so now we have to proceed the given problem. So is we want to search the key element 60 is present in the list or not. So the given problem satisfies the necessary condition, that is given elements are in the ascending order. Okay, now so this is, we have to put the indexes. This is 0, 1, 2, 3, 4, 5, 6. So first element in the array can be treated as low value. Last element in the array can be treated as high value. Okay, next, first we have to find the mid value. So mid is equal to so low plus high by 2. Low plus high by 2. So here low plus high by 2. Low value is 0. High value is 6. So 0 plus 6 by 2. So that is equal to 3. Now A of mid is equal to 3. So mid value is equal to 3. So A of 3 is nothing but 40. So here key element is equal to what is the key element is there? That is 60. Okay. So by using the mid value, the given list is divided into two parts. Before the mid value, this is the left sub array. After the mid value, that is right sub array. So that is 10, 20, 30. So this is left sub array. 40 is the key element. Next, after the 40, 50, 60, 70. So this is right sub array. Okay. Before the mid value, what are the elements are there? That elements belongs to the left sub list. or left sub array. Left sub array. So this is the mid value. What are the elements after the mid value? That elements belongs to the right sub array. Right sub array. Okay. Next, our key element is 60 is compared with the mid value. Our key element 60 is compared with the mid value. So our key element is greater than 40. Okay. So our key element 60 is compared with the mid value 40. So 60 is greater than 40. 60 is greater than 40. Then search continues. Then search continues in the right sub array. The right sub array. Ignore the left sub array. Ignore the left sub array. Okay. So now consider the right sub array. Now consider the right sub array. That is 50, 60, 70. Okay. Now we have to take in. So 50, 60, 70. So this is a low value and this is high value. What are the indexes are there? So 4, 5, 6. Okay. Next. Now we have to find out the mid value. So mid is equal to 4 plus 6. Low value is 4, high value is 6. 4 plus 6 by 2. So that is 10 by 2. That is mid value is 5. So that is A of mid. A of mid is equal to 60. A of mid is equal to A of 5. So A of 5 is equal to 16. Now key element 60 is compared with the mid value. Compared with the mid value. So then key element is equal to the mid value. So therefore key is equal to A of mid. So key element is 60 equal to A of mid is A of 5. So 60 equal to 60. So therefore our key element is present in the list. So search is successful. So search is successful, comma, key element is found at sixth position. At sixth position. So 5 plus 1, that is sixth position, or fifth position. Here we are starting at 0. So then key element is found at fifth position. Suppose we are starting with the 1, our key element is found at sixth position. So in this way, we have to find that our key element is present in the list or not. So if the key element is found in the given list, then search is called as successful search. Suppose if the key element is not found in the given list, so then the search is unsuccessful. Now consider another example. So there are the given elements. Our key element is 95, is found in the list or not by using binary search. First, we have to check the necessary condition while searching a given element in the given list using binary search. What is the necessary condition? The elements in the array should be in ascending order. So here the elements in the array is already in the sorted order: 7, 11, 15, 17, 20, 24, 35, 71, 89, 90, 92, 95. Already in sorted order. Now we have to use the binary search technique. Okay. So a binary search technique follows the divide and conquer technique. So in the divide and conquer technique, so we have to use two phases. One is divide phase and second one is divide the given list by using the mid value. So then we have to get two sublists. So before the mid value belongs to the left sublist, after the mid value belongs to the right sublist. Again, this procedure is repeated until our key element is present in the list or not. Okay. So then we have to put the indexes, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 12 elements are there in the list. The first element index start with 0, last element index is end with 11. The first element can be treated as low value. The last element can be treated as high value. Okay. First, we have to divide the given list into two parts by using the mid value. So here mid is equal to, so low plus high by 2. Low plus high by 2. So here low value is 0, high value is 11. So 0 plus 11 by 2. So that is 5.5. We can take the floor value. Floor value is 5. Now we have to divide the given list into two parts. Before the mid value, low to before the mid value, that elements belongs to the left sublist. After the key element, after the mid value to high value, that elements belongs to right sub array. So here 7, 11, 15, 17, 20. So these elements belongs to the left sublist, and key element is 5. Mid value is 5. Next 35, 71, 89, 90, 92, 95. So this is mid value. So this is right sub array, and this is left sub array. Okay, before the mid value, that elements belongs to the left sub array. After the mid value, that elements belongs to the right sub array. Okay, now our key element is compared with the mid value. So key greater than A of mid value. So our key element is 95 is greater than A of mid. Mid value is 5, A of 5. So that is equal to 95 greater than A of 5. A of 5 is 24. So 95 greater than 24. Our key element is greater than the mid value. Then our search continues in the right sub array and ignore the left sub array. So key element 95 is greater than the mid value 24. So we have to search the right sub array and ignore the left sub array So the right sub array is what are the elements in the right sub array? That is 35, 71, 89, 90, 92, 95. What are the indexes are there? 6, 7, 8, 9, 10, 11. Again, this is low value and this is high value. Okay. So again, this list is divided into two parts by using the mid value. So here mid is equal to low plus high by 2. Low value is 6, high value is 11. So 6 plus 11 by 2. So that is 8.5. So that is, we can take the floor value 8. So our list is divided into two parts based on the mid value. So that is, before the mid value, that elements belongs to the left sub array. After the mid element, the elements belongs to the right sub array. So this is left sub array and this is mid value and this is right sub array. So now we have to compare the key value and mid value. So now we have to compare the key value 95 with the mid value 89. Okay, so 95 greater than 89. So we have to consider the right sub array and ignore the left sub array So here our key element is 95. This 95 is compared with the mid value, that is A of 8. A of 8 is 89. So 95 is compared with the 89. So 95 is greater than 89. So 95 is there in the right sub array. So now we have to consider the right sub array and ignore the left sub array. Okay, so therefore we have to consider right sub array 90, 92, 95. Okay, so what are the indexes are there? So 90 is 9, 92 is 10, 95 is 11, and this is low value and this is high value. So again we have to find out the mid value. So by using this mid value, so divide the list into two parts. So here mid is equal to low plus high by 2. Low plus high by 2. So here low value is 9, high value is 11. 9 plus 11 by 2, that is 10. Okay. So again we have to divide the list into two parts. So 90, before the mid value the elements belongs to the left sub array. After the mid value the elements belongs to the right sub array. So this is left sub array and this is mid value and this is right sub array. So the left sub array contains only a single element, that is 90. The right sub array contains also a single element, that is 95. Here mid value is 92. Our key element is now our key element 95 is compared with the mid value A of mid. So that is A of 10. That is A of 10. So that is equal to 92. So here 95 greater than 92. So hence we have to search the 95 is greater than 92. So then we have to search the right sub array and ignore the left sub array So the right sub array contains only a single element. So this is low value and this is high value. Okay. So what is the index of 95? That is 11. So now again we have to find out the mid value. So mid value is equal to low plus high by 2. Low plus high by 2. So here low value is 11 plus high value is also 11. 11 plus 11 by 2, that is 11. So mid is A of 11. So our key element is compared with the mid value. So here key is less than equal to A of mid. So that is key element is 95 equal to A of mid is 11. So therefore 95 equal to 95. So our key element is found at 11th position. At 11th position, starting with the 0. Starting with index 0. So search is successful. So search is successful. Okay. Now our key element is 95 is found in the list at 11th position. So starting with the index 0. So our key element is found in the given list. Then we can say that search is successful. So in this way, we have to solve the given problem. Our key element is 95 is present in the given list. So then we can say that search is successful. Suppose our key element is not found in the given list after performing this procedure. So then we can say that our search is unsuccessful search. Okay.